Hello everyone, welcome back to another lecture video on mechanics of machinery. So we have already discussed the gear trains. So gear trains are simply combination of two or more gears which are connected to transmit the power from one shaft to another shaft. And we have also seen the classification of gear trains based on the arrangement of wheels. So in this video we will be studying in detail about the compound gear trains. In last video we have studied about the simple gear trains, and about reverted and epicyclic we will be studying in the coming videos. So compound gear trains, we will be first seeing an animation of this compound gear train. So here you can see the central shaft is actually carrying this two gears and the other shafts are carrying a single gear only. So this is in mesh with this gear, and the same another gear which is coming on the same shaft is driving the final output gear. So this is the input gear driver and this is the final output or driven gear. So compound gear train, in compound gear train there will be some shaft which may carry more than one number of gears. Then the gear train will be known as compound gear train. So when there is more than one gear on a shaft, then it is known as compound gear train. And the same a similar schematic diagram also you can see here. Here this will be this I am naming or numbering it as this is 1, 2, 3. So 2 and 3 are coming on the same shaft, so which is carrying more than one gear, and this is the final number 4. So here you can call this as the driver, and this one you can call as the driven. So the velocity ratio will be equal to the velocity of driver omega 1 by omega 4. So here if you are observing 1 and 2 are coming in mesh, so you can write the ratio omega 1 by omega 2 if the number of teeth on this are T1, T2, T3 and T4, then omega 1 by omega 2 will be equal to T2 by T1. And you know that the gears 2 and 3 are coming on the same shaft, then you can have omega 2 is equal to omega 3. And finally the ratio omega 3 divided by omega 4 will be equal to T4 divided by T3. So if you are multiplying this omega 1 by omega 2 into omega 3 divided by omega 4, since you are having this omega 2 equal to omega 3, this terms will be getting cancelled, and finally you will be getting this omega 1 by omega 4, and this is known as the velocity ratio. And velocity ratio for this one you can obtain as, for omega 1 by omega 2 you can substitute T2 by T1, and for omega 3 by omega 4 you can substitute T4 by T3. So this is the expression for the velocity ratio of a compound gear train. So if you are observing in the final expression, all the number of teeth, that is T1, T2, T3, T4 are coming in this one. But in the case of the simple gear train, the intermediate gear teeth numbers are not coming in the velocity ratio. That means they were known as idlers or idle gears. But here the number of teeth on intermediate gears or this shaft are having influence on this gear train, that you can see from this expression. So this is all about the compound gear train and its velocity ratio. So here we will be solving a simple problem. So here we have a problem. The gearing of a machine tool is shown as in figure, and here you can see or you can verify that it is a compound gear train, as here the gears B and C are coming on a single shaft, and similarly the gears D and E are also coming on a single shaft. Here the speed of the gear A is given, which is rotating at 975 rpm, and here we have to find the speed of final gear F, where the number of teeth on each gears A is 20, B 50, C is 25, D is 75, E is 26 and F is 65 are given, and finally you have to find the velocity ratio of F. So here if you are observing, gears A and B are in mesh, so you can write omega A divided by omega B will be equal to the number of teeth TB divided by TA, and B and C are coming on the same shaft, so you can write omega B equal to omega C, and C and D are coming in mesh, so you can write omega C by omega D is equal to TD divided by TC, and D and E are coming on same shaft, so you can write omega D equal to omega E, and finally E and F are having a mesh, so omega E by omega F is equal to TF divided by T. So if you are multiplying this omega by omega B into omega C by omega D into omega E by omega F, since you are having omega B equal to omega C, these two terms will be getting cancelled, and also omega D equal to omega E, so finally these two terms will be getting cancelled. So finally you will be having this omega by omega F and for this gear train these are the ratio of input and output or driver and driven, which is known as velocity ratio. So this can be found as, first term is for omega a by omega b, you can write it as TB by TA into, for the second term omega c by omega d, you can write TD by TC, and for the final omega E by omega f, you can write TF by T, where T is representing the number of T. So here it is, all values you are having. TB by TA is 50 by 20 into TD by TC, TD is 75 and TC is 25 into TF by T, which is 65 divided by TE is 26. So from this one you can solve, whereas this omega value is given, which is 975 rpm, and finally if you are solving you can find the value of omega f. So if you are substituting correctly, the speed required for this angular velocity of gear f will be getting in the 52 rpm. So this was a simple problem. Here we have solved a problem for the compound gear train. Hope you understood, and thanks for watching.